Hello everyone, today's video is on determination of economic dispatch output and production cost for the unit combination and system load level using MATLAB. So I'll be following this book, Power System Analysis by Stevenson. And here in article 13.7 you will find unit commitment. I will be using this rules and all the equations for solving the problem. So here let me go to the page first. Okay, here is the unit commitment in 13.7, and here you can see this daily load curve. Here we will be using this load curve to solve a problem that is given after some page here. So here the duration is 0 to 4 hours, and you can see 6 stages, but here 1400 and 1100 both the stages have the same demand, so they will be calculating all the values for 4 stages only: 1100, 1400, 1600 and 1800. So let's go to the math. Here there are our information given, and here is the output. We need to make a table like this. So here the generating unit number 1, 2, 3, 4. So there are 4 generators where the minimum and maximum power production capability here are given in megawatt, and here the fuel cost parameters A, B, C. We will be using these parameters to calculate the value of lambda and then the power and then the cost. Here the power for 4 generating unit, and then cost, and then total cost, and total cost is multiplied by 4, you can see here. So this 4 is actually from this load curve, daily load curve that we have seen previously. So here you can see the duration is 0 to 4, 4 to 8, so the gap is 4 hours, so we are actually multiplying it with 4. And here the combination we will be taking x1, x2, x3 and x9 that actually matches our load requirement. So we will take this combination. 1 means which unit will turn on and 0 means which will turn off. So here, and if you actually check, other combination will not actually work in these cases. So here this 4 combination, for this we will find these values. And here are the equation. If you go to the first of this chapter, you will find these equations for lambda, then PG1, that means unit 1's power, unit 2's power, and here A total, B total. You will find the values by using these equations. So I have this problem in this slide. I will be using this one. The values are same. You can use the one from the book. I'm just using this one so I can actually easily take the values, and all the things are actually in same place. That is why. So here let's start the coding. Here you can write minimum or mn. I'm just writing short form for minimum and mx for maximum. I need 3 more array for A, B and C, 3 parameters, and here we need to put these values in these arrays. So here let's write the values first. So for minimum it was like this, and then maximum, okay, 625, and then 600, then 500. And now value of A, B and C: 0.0080, 0.0096, 0.0100, 0.0110. Then B 0.8, then 6.4, 7.9 and 7.5, 500, 400, 600, 400. And after this, okay, we need to create another combination here, but before that let's show them first. Okay, there's some error. Okay, now we can actually show our inputs like this if you want to show it. And I'm just using the transpose of this matrix because they are actually row matrix. I'm showing it in a column, that is why. Okay, so these are all our input value, and now we will use this for the next step. So here these are our combination, and for all of this combination there are 1 and 0's combination, like 4 units are on, then all of them will have 1, and here the last one will be 0 1 1 1 0, and this combination will be 1 1 1 1 1 0 1 and 1 1 0 0. So here the combination I will write it in an array again. Let's write it com, and the first one is 1 1 1 1, then 1 1 1 0, then 1 1 0 1, and then 1 1 0 0. So these are the 4 combination here, and the PGT is actually our total power stages, that is actually generated, that need to be generated in from our generating units. So here I will run a for loop for 4 times because there are 4 stages, or for 4 power demand. And here let's print the stage number first. I will display it with the stage number, or with the value of the demand. So here I will be using string to character, and here integer to str, that will convert the integer to string, and they will show the value from that PGT array. Okay, I have not given a variable here. Okay, I wrote the name printf, that will be the correct form. And here I think I have forgotten some brackets here, some parentheses. Okay, there is some more error. Okay, the last one is actually not included. Now this is alright. You can see all the stages here. The loop is actually going on for 4 times. And here you can see that some of them are infeasible and some of them are feasible. So we need to make sure that if it is infeasible, we can actually determine which one is infeasible or which one is feasible. So here, for that we need to actually check that if we use all the maximum values, if the total capacity, by using this maximum value, if we can meet that particular demand for power. So we will check the capacity. For that we need to run another for loop here inside this, that will be j 1 to 4, and in between them we will check the capacity. So capacity will be equal to 0 at first, and then we will count it inside another for loop. So we will take a variable called check, and here the capacity equal capacity plus, here we will check all the capacity for all these 4 unit, and then we will sum them. That is why we are actually checking for each time, and then we are adding it to the previous capacity value. And after that we will take the maximum value position here 1, because there is only 1 row, and then check will be the number of column. Okay, and then we will actually take the combination, because we can actually get from the combination which unit are on or which unit is off from this combination. So we will take this as a 2-dimensional array using j and check. So combination j comma check, and after this let's put a semicolon here, and let's check the capacity and the value of our demand for that stage to see if the capacity is more than the value of this power demand or not. If the capacity is more, that means that combination can actually fulfill that demand. But if it is less than the power demand, then we cannot actually fulfill that demand by that combination. Here you can see demand is 1100 and capacity is 2013 something. So they can actually fulfill that demand 1100. And here if we go to the last stage, here you can see the capacity is less than the power demand. That means this combination is actually infeasible to fulfill our demand. So we will just write that condition in an if condition to check if the capacity is greater or not. and if it is not, we will write infeasible in that case. So if capacity is greater or equal pgt1, z, and then else condition, then okay, first let's write the else condition here. We will display infeasible, and let's run this one. So here you can see that in 1400 we have one infeasible, in 1600 one, and in the last stage there are two infeasible stage. So as we can see, this actually matched properly. Now we need to write the if condition to show the value of the other things. So first we will just declare the two variable, that is a inverse equals 0 and b total equals 0, and then we will start our for loop for 4 times, as there are 4 unit and 4 stage, so we will just write it like this. Then we will start our if condition. So if the combination is true, then we will just calculate the a inverse, and you can actually check the equation from the book. We need to inverse them, and then we need to add them together after inversing them, and then we need to inverse the total a inverse. So we will do that after we end the for loop, but before that we need to calculate the b total. So here bt was actually equal to b divided by a, so we need to close this one too. So after this we will inverse that a inverse. So a inverse will be a total will be equal to 1 divided by a inverse. Here you can see the inverse, and here we will calculate the lambda. So lambda is actually at into pgt of 1, z plus bt. Okay, let's represent lambda with L, capital L, and here we will run another code, another for loop. So here we will calculate the total power for each unit, and we will keep them in another row array. Or row matrix actually, and here we just need to round them up so that we don't get the fractional value. Okay, then after this we will run another for loop, and we will calculate the total cost. We will also keep them in another row matrix, and here I'm just using the simple equation, half into a into pg unit, for which unit the power will be there and that will be squared, then b into pg and plus c. Let me just check the equation once more. So we are getting the individual cost for each unit, and then we need to calculate the total cost, but before that we need to add the combination here, so that you can see that if the combination has a 0, that value will not be calculated for cost or power both. So we need to just add the combination condition in every calculation we do in this case, and after that cost will be round of cost. We will just take the integer value, and then total cost will be summation of all the value of cost. As it is all the value, we don't need to actually write another loop. We can write it like this, and we will just multiply them with 4. As we have seen previously, there are the duration 4 hours between each stage, and here we will just create another row matrix, and there we will just put all this value that we have calculated till now inside that matrix or array. Okay, then we need to just show this or print this. Here if printf, we will show this inside this single quotation %3f, and that means that we will show the value of the first element, that means lambda, in 3 decimal point. Then all the other things will be actually for 0.0f, %.0f, and then the last one Then we will print a new line, and here we will show the values, all the values. Okay, now you can see all these values, they're just a bit displaced here, but all the values are actually showing properly. You can match them with the value from your book. Okay, let's check the value of lambda, and here in the last stage you will find the error, that in this one we will get some error, because here you can see that 680 is the second unit's power generation, but here the maximum limit is 625. So we need to actually correct the lambda value of lambda to actually get these values, and for that reason we need to modify the code a bit for this kind of case. This is actually rare case, but it can happen. So let's just do this again. For that we need to go to our if condition again. So here, if capacity is greater, then only we will do this, otherwise it is infeasible. So here we need to create another variable called add equals 0, and then okay, we will just use this add variable for keeping track of all these value that we need to actually generate, all the excess amount of value that is actually we need to generate after giving the maximum value to each of the units. So here, after counting all the powers for each unit, we need to run another for loop. Let's call the variable v124, and inside this we need to write a condition. If the unit power that we calculated previously is greater than maximum value, our array name was actually mx, so mx of v. So we will check if the value is greater than the maximum value. The maximum value was 625, so it is actually greater than the maximum value. So here we will go inside this if condition. So what we need to write is that we need to create another temporary variable, and we need to take this variable and assign it inside this temporary variable. Then we will just assign the maximum value to this variable, to this unit actually. So here, because we cannot actually assign more than maximum value, so we are giving them the maximum value, and then we will check how much amount we need to produce by using other units. So here temporary variable will be temp minus the maximum one, because we have actually given the maximum value to the unit, so we will just delete it and we will get the difference between them, and that will be actually added to our add variable. So we are giving the maximum value to that unit and we are getting that difference, then we are adding that difference with our add value. So add is actually keeping the track of remaining unit that we need to generate by using other generating units. So we are ending that if condition here, and after this we need another if condition. So they will check if the add variable is 0 or not. If it is 0, then we don't need to do anything, because we don't have to then reproduce by using another unit, because it is already 0. But if it is not 0, then we need to do this loop. So here again a for loop for 4 times, and then inside this for loop we will write other if condition. If pg 1, w not equal to 0. Okay. When will it be 0? When the combination is actually showing that the unit is shut down. That is why that will be 0. So we cannot use that unit. So we are just checking that condition by using that if it is 0 or not. If it is not 0, that means that unit is running properly. So we need to check if it is less than the maximum value. If it is less than the maximum value, then we will have some scope to actually produce some more power from that generating unit. So we are checking if it is less than the maximum capability that it can actually produce, and if it is, then we will take the difference. So let's get the difference and take another temporary variable here. Let's say temporary 1, that will be equal to maximum of W minus PG 1 comma W. So we are getting this difference. That means we can actually produce this amount, this temporary 1 amount by using this unit. And then here we are actually checking if the temporary 1 is less than or equal to this add variable. It can be less than or it can be greater than. Okay, so we need if else both condition. So let's see if the temporary 1 is actually more, that means this unit can actually fulfill our total condition, total demand. Let's say we need 50 megawatt, we need more 50 megawatt more to generate, and this unit can actually generate 100 megawatt. So we can actually give all this 50 megawatt generation work to this unit. That is what we are doing here. So in this else condition, that means temporary 1 is greater than the add value. So we are actually adding that add value to the already existing power of this unit, and then we are just calculating the lambda, because we have actually produced all the unit that we need to generate. Our work is done in this case if the temporary 1 is greater than the extra amount of unit that we need to generate. But if it is not the case, then we need to go to this if condition. That means now add value is more, so we can actually give some amount from the power we need to this unit. Then we will have some excess amount that we need to actually assign to some other unit. Okay, so here we are just assigning the maximum value that this unit can generate, and then we are actually getting the difference again. We are doing this exactly same like we have done previously. Then we just added that value inside add, and now if we run, you can see in the last stage here to 625 and 625, it has automatically changed the actually things here. They are giving the maximum value to these two unit 1 and 2, and the remaining one is actually transferred to the unit 3. And here we can actually show our input and output like this, and we can show some line here to display what are the name of the values. First one is lambda, and then there was our PG 1 2 3 4, then F1 F2 F3 F4, the cost, and then total cost. So here you can adjust the space to adjust that position of this display message. So that's how we actually calculated all the value of the power by using economic dispatch, and next we will actually use this for unit commitment.